In this video, we are going to learn 10 questions from the book Concepts of Physics Volume 2, and the chapter is Electric Field and Potential. Question number 1 to 50 already we have seen in previous 5 videos. The link for the same you can find in the description below. Now question number 51 is saying that a block of mass m having a charge q is placed on a smooth horizontal table and is connected to a wall through an unstressed spring. The spring is kept in its natural length, having the spring constant k as shown in figure. A horizontal electric field E is parallel to the spring is switched on. Find the amplitude of the resulting SHM of the block. See, if we see the horizontal electric field in the direction shown in the diagram, it is going to apply a force F is equal to QE. M, when it is going to experience this amount of force, would now moving away from its path, it means spring is going to be elongated. Now spring would be applying some restoring force. That force will be F is equal to Kx or minus Kx, because in opposite direction to the applied force. And this force, which is restoring force, is now responsible to balance the QE at equilibrium. X we can take, which is elongation in the spring, we can take as amplitude of SHM as well. So X value will be nothing but QE upon K from this particular simple question. Question number 52. There is a charge Q which is placed on a smooth horizontal table, and in front of it there is a vertical wall. The electric field is switched on in that direction towards the wall. The distance is given d. Now the question is, assuming elastic collision, find the time period of the resulting oscillatory motion. Is it a simple harmonic motion? So first of all, let us calculate the force acting on the charge. It is QE. Now because of this force, the charge is going to be accelerated and it starts moving towards the wall, and it will cover a distance d with some acceleration. Acceleration is QE upon m. How much time would be involved in order to complete the distance d? That we can calculate by the formula S is equal to ut plus half at square. Once we put d, the distance S as d, and then 0, because u is 0, half QE upon m into t square. T is nothing but under root 2 dm upon QE. The collision is elastic, it means it has to come back. It has to come back, and then because electric field again is pointing towards the vertical wall, it would now reduce its speeds. Momentarily it will come to rest from where it has started, and then again it will move towards the wall. Again after hitting, because the elastic collision is there, it will come back. So it does perform the simple harmonic motion, having time period as time taken to complete one full rotation, going time plus coming time. So going time we have calculated t is equal to under root 2 dm upon QE. Total time or time period will be 2 into small t, that is 2 under root 2 dm upon QE. Question number 53. There is one uniform electric field of 10 Newton per coulomb exists in the vertically downward direction. Find the increase in the electric potential as one goes up through a height of 50 centimeter. Let us take this as external electric field. The field strength is 10 Newton per coulomb, and one material is moving up with a distance 50 centimeter. What we have to do? Electric field and potential, the relation is there, E is equal to minus dV upon dr. So dV is equal to E into dr. Electric field and movement both are in opposite directions, so minus and minus would be plus. The electric field is 10 Newton per coulomb. The displacement is half meter or 0.5 meter. So after multiplication, the raise in potential would be, or increase in potential would be 5 volt for this particular object. Question number 54 is saying that 12 joule of work has to be done against an existing electric field to take a charge of 0.01 coulomb from A to B. How much is the potential difference is therefore that is VB minus VA. Again, potential difference is equal to nothing but work done per unit charge, or there's the definition itself that change in potential energy per unit charge is equal to change in potential difference. So VB minus VA is equal to work done 12 joule upon charge. It is nothing but 12 into 10 raised to 2 or 1200 volt. Now number 55 is saying that two equal charges 2 into 10 raised to minus 7 coulomb each are fixed at separation 20 centimeter. A third charge of equal magnitude is placed midway. Midway means 10 centimeter from both. Between the two charges. It is now moved to a point 20 centimeter from both the charges. How much work is done by electric field? See, when it is presented this particular situation, what is the energy of the charge which is being placed in between these two charges? We can calculate. When it is moving from its midpoint to the perpendicular bisector at a distance 20 centimeter from both, what is the energy at that point of time? We can calculate, and if we can find the difference, that will be the total amount of work done. So charge is given because charge of all three is given as 2 into 10 raised to minus 7 coulomb. So U1 means the electric energy when it was placed in between. Because of both the pairs it will be same, so I have multiplied already by 2, K Q1 Q2 upon R. You put all the values and we will be getting 72 into 10 raised to minus 4 joule. Then when it is taken to its perpendicular bisector at a distance 20 centimeter from both, again we are calculating U2. The formula is 2 K Q1 Q2 upon R. Now distance will be taken as 0.2. So energy will come 36 into 10 raised to minus 4 joule, and work done is equal to change in potential energy, that is 72 minus 36, that is 36 into 10 raised to minus 4 joule is the final answer. Question number 56. There is an electric field 20 Newton per coulomb along x-axis. The direction is given, it means we can say 20 I. Calculate the potential difference VV minus VA where the points A and B are given by the point A, B is given in terms of coordinate system, coordinate points, that is A is given 0, 0, B 4 meter 2 meter, then in B part A 4 meter 2 meter, and so on and so forth. We know that change in potential is nothing but electric field into distance. Electric field is given along x-axis. How much distance or displacement is being covered along x-axis? If we can multiply, we can get the answer. We have nothing to do with 0, 0 or 4, 2m. We need to check in or a point A coordinate, coordinate of point A, what is the x, coordinate of point B, what is the x. We don't have to do anything with the value of y which is given in A or in B. So in A, x is 0, B, x is 4 meter. So displacement will be 4 minus 0. Electric field is 20, 4 minus 0, it is nothing but 80 volt. For B, if we talk, it is a 4 meter, 2 meter, 6 meter, 5 meter, means A, x1 is 4 meter, B, x1 is 6 meter. So displacement will be 6 minus 4. We have nothing to do with the y coordinate. Then it will be 40 volt. If you take C, it is 0, 0, 6 meter and 5 meter, so 6 minus 0. It will be 20 into 6 minus 0, it is 120 volt. In the question, one more part is being asked. Do you find any relation between the answers of part A, B and C? We can see the potential difference in part A plus potential difference in part B is nothing but equal to the potential difference which we have calculated in part C. Now 57 question I have taken to the same slide because it is related to question number 56. The question is, consider the situation of previous problem. A charge of negative 2 into 10 raised to minus 4 coulomb is moved from the point A to B. Find the change in electric potential energy UB minus UA for cases A, B and C. So if we take the formula or the relation between the change in potential to the change in electric potential energy, it is V, or change in potential is equal to change in potential energy per unit charge. So change in potential energy is equal to charge into change in potential. Now change in potential already we have obtained. Look here, in case A, change in potential is equal to change in potential energy is equal to change in potential into charge. So change in potential is 80, charge is 2 into 10 raised to minus 4. We can just multiply and that will be the amount of work done. Similarly in part B, 40 into 2 into 10 raised to minus 4, it is 8 into 10 raised to minus 3 joule. In C part, it is 120 into 2, so it is 2.4 into 10 raised to minus 2 joule. So this is the part of question number 57, respectively in A, B and C. If you want to make a note of it, you can write it individually because they were connected. So I have taken both on the same slide. Question number 58. Electric field is given, it is in XY plane because it is given 20I plus 30J. And the question is being asked, if the potential at the origin is taken to be 0, find the potential at 2 meter, 2 meter, means along X 2 meter, along Y 2 meter. If we want to write this in the vector form, we can write 2I plus 2J meter. And we know E is equal to, or dV is equal, E is equal to minus dV upon dr. So dV is equal to minus E dot dr. If we take magnitude only, E dot dr dot product, we know I would be multiplied, or coefficient of I would be multiplied to the coefficient of I, coefficient of J would be multiplied to the coefficient of J. So 20 into 2, 40, and 30 into 2, 60, and the change in potential is going to be 100 volt. That is the answer. 59. There is electric field given along x-axis, and that is not uniform electric field, rather non-uniform electric field, because as x increases, electric field is going to increase. Where A is given 10 volt per meter square, take the potential at 10 meter, 20 meter to be 0, find the potential at origin. That is the question. Now again same formula, dV is equal to minus E dot dx we are going to apply, but E, if we are taking as 10x, because A is given 10, x is variable. If we want to calculate total potential difference, we have to integrate this. We are taking magnitude only, E dot dx, E value is Ax. We are going to integrate this from 0 to 10, because in the point, the coordinate point, the x-axis is 10 meter only, 20 meter is the y-axis, we have nothing to do with that. So potential will be 0 to V. The right side integral part will be having the variable from 0 to 10. A would be coming out. X dx integration is add 1 to the power, divide by total power, so it will be x square upon 2. If you are taking A outside or A by 2 outside, put higher limit minus lower limit, 10 square minus 0 square, it is nothing but 100. 100 upon 2, A is 10. So after multiplication, it is nothing but 500 volt. One formula which we have used here for the integration, that is very first formula, x to the power n dx, or integration of x to the power n dx. What we do? We add 1 to the power, we divide by total power. Here x is having or carrying only one power. So if we are going to add 1, it will be x square upon, now 2 is the power, so upon 2. That is the formula we have borrowed from integration. Question number 60 is saying that electric potential existing in space is V, and that is given in terms of A, xy plus yz plus zx. Write the dimensional formula of A. See, potential is given in terms of A into xy. We know that x is distance, y is distance. So Axy plus Ayz plus Azx, if we are taking, V is nothing but volt, and A into xy is nothing but volt only, because we know that in a particular equation, if two or more quantities are added, subtracted or equated, each and every quantity would be having same dimensional formula. Each set, I'm not saying that individually, like AXY, same dimension as AYZ, same dimension as AZX. Same dimension would be there for the voltage, and in SI unit, same system is going to be. So if you are taking A, it is nothing but voltage upon XY or voltage upon YZ or voltage upon ZX. So voltage, that is potential, is V is voltage, that is volt, upon X meter, Y meter, meter square. So SI unit will be volt per meter square. Accordingly, we can write the dimensional formula. Potential dimension is work done upon charge, work is ml2 t minus 2, charge is it, length is L, so L2. On simplifying, we will be getting ml0 t minus 3 I minus 1, that is the dimension of A, or dimensional formula of A. Now B part is there. Find the expression of the electric field. Expression of the electric field, E is equal to minus dV upon dr. Because it is given in 3D coordinate system, so we can differentiate along all three directions. So minus dV upon dxi minus dV upon dyj minus dV upon dzk. And if we are taking the first dV along the value, it is dAxy plus yz plus zx upon dx. Now this could be differentiated only which is carrying the term with x, like yz, it will be 0. In the second term, xz, it will be 0. In the third term, xy, it would be 0. So after differentiating, we will be getting a y plus zi, a x plus yz, a y plus xk. And after simplifying it more, if minus a is kept common, it will be y plus zi, x plus yj, y plus xk. C part is saying that if A is equal to 10 units, find the magnitude of electric field at 1, 1, 1. Means x is equal to 1, y is equal to 1, z is equal to 1. Put the value in the previous equation. It is minus 10, 2i plus 2j plus 2k, or minus 20i minus 20j minus 20k. Magnitude of E, if we want to calculate, it is under root coefficient of I square plus coefficient of j square plus coefficient of k square. It is 20 root 3, and it is 20 into 1.732, and it is 34.64 Newton per coulomb. That is the total electric field. Thanks for watching.